a national caterer determined that 37% of the people who sampled their food said it was delicious. A random sample of 144 people is obtained from a population of 5,000. The 144 people are asked to sample the caterer's food. If p hat is the sample proportion saying that the food is delicious, okay, so they've defined it, what is the standard deviation of the sampling distribution of p hat? So I'm going to look at it real quick and say, look, p is the true proportion, okay, and let's look. They said a random sample of 144 out of a population sample of 5,000, okay. So what do you guys think that 37 is? What? Where did you get that 53? Yeah, so I don't love the way they worded this. They're saying your p hat is 37%. 37% of 144 is, what did you get, Leo? So 53.28 or 53. And I wonder if I don't think I have the key to this. Which kind of sucks. Oh, please. Sorry, guys, I was supposed to have an hour to go through and figure this out, and after our meeting, it devolved. So what I don't love about this is the way they worded this will be confusing for Chapter 10, because it says a national caterer determined that 37% of people who sampled their food said that it was delicious. It almost sounded like they knew, like they were God. This is the true value, right? But really it's saying, hey, based off of this sample below, this is how they got the 37%. Because 5,000 is the whole population, and they didn't say those 144 people liked her food. They just said they took a sample of 144. So I pulled this up because Slick gave it to us and said this is a good example, but I don't actually like the way they're doing it. Instead, what they should have said is, hey, look, this caterer took a sample of 144 people and 53 liked the food, and then use that to find your p hat. Does that make sense, you guys? So that's what gave me a pause. But and then they usually don't normally tell you the samples, the whole population size. So it doesn't normally show up. All right, but we're gonna go with that. So based off of that, you guys good why that's the p hat, then p hat is x divided by n. How would we find the standard deviation? Look at your formula sheet that's on the back of what I just gave you. How would I find the standard deviation? I'm concerned that it's taking you guys this long to find it. If I am, how would I find the standard deviation? Yes. Yeah, this is where if we're doing samples of proportions, okay? So it would be this formula, the square root of PQ over N, or P hat Q hat over N. So Oops, my computer froze. 1 second. Just waiting on tech. Sorry, guys. Okay. So what they're doing is breaking it down. Okay, and they could say something like, okay, what is the mean of all possible samples of size 144 out of this population of 5,000? And it would be, okay, the 0.37, what we already found. And then what would the standard deviation be? The square root of 0.37 times 1 minus that, 0.63, all over your sample size of 144. Okay, and now it wants the confidence interval. So you should know how to use the formula. If you look right here, here's the box for confidence intervals. It would be this confidence interval right here, that formula. Which would then be p hat, so 0.37 plus or minus z alpha over 2, which, did they say, they didn't say, so should we do it at 95%? You guys good with that? So I would do inverse norm 0.025 to get the z alpha over 2. Why would I do inverse norm 0.025? Leo, do you? Yeah, it's 1 minus 0.95. So 5% is your alpha level, divide by 2, and then that's what you plug in. And it should come out with 1.96. Okay, so that would be, because I did 95%, 1.96, and then you want the standard deviation of p hat, q hat all over n. Yes, question? I made it up because they said do a confidence interval, and if they tell me that and they don't tell me, I just do 95. So yeah, out of thin air. Okay, and again, maybe this was not the best thing to pick, but this is what Sleep had on there as another review, and I didn't want to give you the one you already had the key to. So we will make this be informative. So then you would get 0.37 times 0.63 all over 144. Okay, and so then if they asked you, what's your margin of error, it'd be this part. This would be your E. If you did this plus this stuff, that would give you your upper bound. This minus this stuff, that would give you your lower bound. But again, if they just wanted the confidence interval, I would just stick it in my calculator. And for those of you that are late on the homework, that's how I would be finishing my homework. So real quick. Come on, computer. So I would do stat tests. I was trying to make it so you could see more. All right, there we go. Stat tests. And I would go down to a one prop z interval. And you put in, we had 53 out of 144 with 95%. And there's the interval we would get. Yes, question. So a z interval is going to be using proportions. So think proportions. We had 10 out of 20 people surveyed, and we get a decimal or proportion. Means would be t. Mr. T is a mean guy. Okay. Now notice that my p hat in the calculator is 0.368. That's because we had to figure it out from what she had. She said it was 37%, so we took 37% of 104 and then rounded to get it to work. And again, I don't think they would give you something quite that confusing. No, they would say something like, a recent campaign states the 37%, but they wouldn't make you go back in and find the other pieces. So it looks like they would leave out this extra information that just confused you. Okay? No, just go to the closest. You only round up when you're finding n. All right, so you guys good with that? All right, let's look at their next one. A private opinion poll is conducted for a politician to determine what proportion of the population favors adding more national parks. How large a sample is needed in order to be 90% confident the sample proportion will not differ from the true proportion by more than 5%. So again, you want to look at your formula sheet. This is a very good question. Okay, it comes out right here. We're talking proportions, and it's going to be one of these two. Did they do a pilot or say we think that this is p hat? They did not. So we're going to do it where p hat is unknown. Okay. Now, this is the formula. When I gave it to you out of the book, it looked like this. N equals 0.25 times z alpha over 2 over e squared. Notice how that's the same formula, right? They just put these two, your book puts these two together in parentheses, but it's still the same formula. So if you're more comfortable with the formula you've been using in your notes, great. If you want to use the one directly off of this cheat sheet, great. I'm going to go ahead and use, which one do you guys want? The pink one or the typed one? The pink one, okay. So I'm going to go ahead and use that one because that's the one I have memorized as well. So you just plug it in and said n equals 0.25. We need our z alpha over 2 all over a margin of error squared, okay. We want 90% confidence, so that's how we get the z alpha over 2. 1 minus 0.9 is 10, divided by 2 is 0.05. Inverse norm for 0.05 comes out as 1.64 something, but I'm going to do it again real quick. Yep, 1.6448 or 1.645. Remember, it comes out as negative, but we use it as a positive. So then we just plug it in. That's 0.25 times 1.645 all over. We want the margin of error to be no more than 5%, and then square that. And whatever that answer is, you want to round up. Question? So if this gave us like a population percentage, then we would use that as a 75. Yeah, so maybe they said that we think it's 70%, so you would say 0.70 and then times 0.30. No, everybody keeps asking me for that shortcut. It does not exist. You're like the sixth person that's asked. because you all want it if there's no way to do it. So if you notice on the sheet, this is the equation that's right out of your notes in a gray box. On the sheet right here, they've just reordered it, and I put these two things together, but it's the same equation. Okay? Yes. Yeah. Good call. Go ahead and get it off the printer, dear. All right. So next, M&M candies report that the plain M&Ms are manufactured with 30% brown, 20% red, 20% yellow, 10% orange, 10% blue, and 10% green. I just did this with my AP kids. Below are 3 graphs. One represents the colors of individual M&Ms for the population of all M&Ms. One represents the colors in a sample of 20. And one represents the colors, let's see. And one represents the sampling distribution of the proportion of candies in a 500 sample of size 50. Okay, identify which is which. So again, colors of individual M&Ms for the population of M&Ms versus colors in a sample of size 20. Okay, versus the sampling distribution of the proportion of brown in a sample of size 50. All right, which graph? A is what? Green, orange, or purple? So we're matching green, orange, or purple with A, B, and C. So let's first think about it, okay? The green is relating to this sentence right here, that this is how they do it. They do 30% brown, 20% red, 20% yellow, 10% orange, 10 blue, 10 green. Which graph shows those proportions? Yes. C, right? We don't know what this is, but this could be 30, 20, 20, 10, 10, and 10. So this one has to be C. Now the other one is saying, hey, taking that population, kind of like you guys did with the Skittles, right? What if I just did a sample, one bag of 20 candies? Wouldn't it kind of look similar to this? Right, but just a little variation. Like all of your bags were similar, but they had a little bit of sampling variation. So this one would be B, because it doesn't match the population example exactly, because it was a sample of 20 candies, but it's similar. Now, A is what they're really trying to get to. I knew A immediately when they said the proportion of one color with a sample of 500. Why did I know that the purple one was going to be A? N is over 30. N is over 30 is the right idea. N being over 30 would make what we see happening if it was means, but we're talking proportions. What? It's because it looks normal, but what about the sentence makes me know that, Leo? Yeah, because they took a huge sample. If this was means, they could do the same thing about the mean number of color or whatever, or the mean number of candies in a bag like you're doing with your Skittles. If it's means, N has to be greater than 30. If it's proportions, N times P times Q has to be greater than or equal to 10. They didn't tell us the proportion of brown, right, that they got in the sample. but their N was so big, it's going to happen. As N gets really big, these two don't matter that much, and it's going to get over 10. So the minute they had a really big sample size for a proportion, I knew that this was going to have to be the normal one. Okay? All right, so that is that. The normality condition out of our ring conditions, if you're talking proportions, N times P times Q has to be greater than or equal to 10. And if you're talking means, your sample size has to be greater than 30. Or for both of these, if the original population, like this, was normal, you'd be good. Now, this original population is talking categorical data. They're not talking proportion. They're talking they're talking proportions, but they're talking proportions for each color. Red, whatever, etc., right? Brown. When we do it, we pick one color. When we're doing chapter 8 and 9, it's one color, one characteristic. What's the proportion? You guys good with that? So if you think about your Skittles project, you did this for the first part of your Skittles project, right? You made Pareto charts for all the colors. And then they said, well, they're going to, you don't get it yet. Now they're going to say, pick a red color. Now do a confidence interval for that. So all the colors is looking at it like this. Once they get you down to one statistic, then you can do confidence intervals and stuff like that. All right, any questions? All right, a student randomly selects 10 paperbacks at a store. The mean price is $8.75 with a standard deviation of $1.50. Assuming the prices of paperbacks follow a normal distribution, conduct a 95% confidence interval. So again, okay, N was our sample size. The sample average is 8.75, okay? So let's see, they could ask you something like this. We're going to construct a confidence interval, but they could ask you this. What is the mean of the sample? Well, we'll go back and do that on a different one. We would do X plus or minus T alpha over 2 times S over the square root of N. That is in your formula chart. We're using T because we don't know the population standard deviation. We don't know the mean, population mean. That's what we're trying to find. So you could plug in, we have a sample average of 875. To find this, and they could ask you for this, you would do inverse T, and we want a 95% confidence interval. So again, 1 minus 0.95 is 5%, divided by 2 is 2.5%. And then you have to put in degrees of freedom. Degrees of freedom is N minus 1, so 9. So second vars inverse T, okay, 0.025, degrees of freedom of 9. And we know we need 2.26. So 8.75 plus or minus 2.62 standard deviations. The sample standard deviation was $1.50 divided by the square root of 10, and that would be your confidence interval. They could ask you, hey, what would the t value be for this? What would the standard deviation be? Okay, but if they just wanted the interval, you would do stat tests t interval, and you tell them I have the statistics, not the data. So my mean is 8.75. My standard deviation is $1.50. I sampled 10 people. And there's my interval. Yes. Yeah, you can do that. So it depends on the question. If the question is what's the interval, you just give it to them. But they might ask, hey, what t would you use? Or whatever. They might ask for the pieces, so you have to know how to do both. Margin of error then, if you just put it into the calculator, right, like our answer is how would you find the margin of error? Or how would you find the p-hat if we didn't have it, right? Or I shouldn't say p-hat, x-bar. What if they didn't tell us that the average was this? They just gave us the interval. Wouldn't you do upper plus the lower divided by 2? 9.823 plus 7.677 divided by 2 better get you back to that $8.75. If I wanted the margin of error, I could take the top one and minus it by my average to find out my margin of error. Or I could put that in the calculator. That would also give me the margin of error.
So if they give you the upper bound and the lower bound, that's the find the mean, that's what you do.
Yeah. They could do the same thing with the proportion. Yeah. No. The 0.025 is what you put in the calculator to get T alpha divided by 2.
What is that?
So T alpha divided by 2, this right here is the alpha over 2. So when they're saying T alpha divided by 2, they're saying what is the T score where you have 0.025% of the curve above it. We want this value right here. And that value is at 2.6 standard deviations above average. Right? If it was a normal curve, for everything with a normal, if we say 95% confidence interval, okay, it's 1.96 for every single story problem. But so you can do Z alpha over 2, but you could also just memorize at 95% it's 1.96. At 90% it's 1.645. But with a T curve, the shape of the curve changes based off your number of people in your sample, so you'll have to do it every time. The smaller the sample, the farther you have to go out in standard deviations. And I'm getting a real glare here, so like I can't see Jacob's face. So if you guys need something, you have to like let me know, okay? Question? Again, okay. So real quick, I did stat, tests, T interval number 8, because it's means. Then I put it over to statistics, not data, and I put in my mean and my standard deviation and my number in the sample from the story problem. Now, one thing that we had to know here, if we had checked our written conditions, okay, it was a random sample, right? We'd assume that 10 paperbacks were less than 5% of all the paperbacks in the store. But we did not take our 10 is not greater than or equal to 30. So we don't know it's normal except for this sentence right here, assuming the prices of paperbacks follow a normal distribution. So they covered us in our written conditions. All right, next one. A random sample of 1,345 adult television viewers showed that 52% planned to watch the NCAA finals. The margin of error is 3% with 95% confidence. Does this confidence interval support the claim that the majority of adults plan to watch? Okay, well, let's think about it. They got, out of a random sample, they get this 52%. Okay, so that's our middle. I'm going to write it down here. And I'm going to pull it up here where I can read it while I'm drawing. Okay, so the sample was at 52%, and they did a margin of error of 3%, so they already did the work for us. So the sample is going to go from 0.52 to 0.55 and 0.52 to 0.49, because there is your 3% on either side. And because they tell us that was a 95% confidence level, that means that 95% of all possible samples would fall in here. So we're 95% confident that the true sample, the true value actually falls in there, right? So let's see what it says. Does the confidence interval support the claim that the majority of adult television viewers plan to watch it? Okay, what is the majority? How many for a majority? Yeah, majority is greater than 50%. Based off this confidence interval, is there a chance that it could be less than 50%? Your sample is 52%, so that's promising. Is there a chance it could be less than that? No, it's not. What do you guys think? Yeah. Question. Well, should I say the question again? Okay. So the question is, they took a sample, and their sample makes it look like 52% of the people are planning to watch. But then they made a confidence interval with a margin of error of 3% and 95% confidence. So really, their margin of error is from 49% to 55%. Okay? Based off of that, can we conclude that the majority, greater than 50%, are going to watch the conference? Yes or no? Raise your hand if you think it's yes. Raise your hand if you think it's no. Jacob, why is it no? Yeah. If most of this interval is above 50, right? But is there a chance based off the interval that the true value is less than 50? Yes. So we cannot conclude it. It has to be fully above 50 for us to feel good about it. So let's look at their possible answers. It's not yes. No, the confidence interval means. Yeah, there we go. It's C. Okay. I didn't see who just came in, but I'm printing you wait, who just came in? Are you taking the test? Are you doing this with us? Yeah, are you taking the quiz? Yeah, that's what I thought. Okay, hold on. All right, guys, go on and look at the next one for a sec. So any questions that you saw from 6? Or should I just go over it? Just go over it? Okay. Considering confidence interval estimates for both mean and proportion, answering the questions. When you increase the confidence level, what happens to the width of the confidence level? Does it go up or down? It widens, it goes up, it increases, right? If let's say we were talking proportions, all right? So for a 90% confidence interval, when you do inverse norm, you get that you need 1.645 standard deviations. If you wanted a 95% confidence interval, you get that you need 1.96 standard deviations. It's going to make your margin of error wider. Okay? Think about it. The more confident you are, the wider your net is that the real value is in there. When you increase the sample size, what happens to the width of the confidence intervals? Either way. And remember, we have so as this number gets bigger, what happens to the width of our confidence intervals? They decrease, they get smaller because, right, if this number gets bigger and you're dividing by that number, then your standard deviation is going to get smaller. As n gets bigger, then you are dividing by a bigger number. So the standard deviation gets smaller, and you build your confidence intervals on how many standard deviations away do you need to be confident. Okay. In a recent poll of 900 randomly selected adults, 37% reported that they could not swim 25 yards, okay, the length of a typical pool. So I'm not going to do this one because you should just be able to, oh, I guess we should. Fine. How many more are there? You guys want to do them all? Okay, we'll just do them. All right. So if I were you, I'd put this right in your calculator. Okay. So this time it's stat tests 1 prop z test. Or sorry, 1 prop z int, 1 prop z test is next week. All right. They reported that in a recent poll out of 900, 37 reported that they could not swim. So this x is going to be 900 times 0.37 because it's 37% said they couldn't swim. So that's 333. If that was a decimal, round to the closest number out of 900. And I want a 95% confidence interval, so that's what I have. Yes. Tens, hundreds, thousands. 0.33846. I'm going to round in a minute to 0.40154. So they really want 0.338, comma 0.402. Question, yes. So X is the number that said they couldn't do this, right? And that was 37%. So 37% of the 900 people surveyed. Okay. So there's our interval. Now it says, what is the margin of error? Well, the margin of error is the difference from this middle value, 0.37, and either the top or the bottom, right? So 0.402 minus 0.37 is your margin of error. And they don't call it M of E, they call it E. Now, I am going to pause for 1 second and look something up on the final to make sure. Sorry, let me say it again for the video. What would the formula have been for this margin of error? So upper bound minus lower bound divided by 2 would actually give you the p hat, would give you the middle 37%. How would I find the formula? Like if I didn't actually already have the interval, wouldn't the formula part be the z alpha over 2 times the square root of p hat q hat over n? That would be the formula, that's the margin of error. Does that make sense? That's your error, because you take your statistic, your p hat, plus or minus your margin of error. The amount of money a college student spends each semester on textbooks is normally distributed. So again, that's the, and I'm going to show you where that is. I'm not going to write that there. I'm going to show you here. That is right here. Right here it is for proportions. Here's the whole thing for proportions. So this part's your error. Right? Z times, and then this is what it would be for means. This part right here is the part for the error. All right, so you're centered. Do you still need that, Jacob? Are you good? Okay. You're centered at $195 with a standard deviation. So you could say this: X equals the amount of money college kid spends on textbooks. X is approximately normally distributed with a mean of 195 and a standard deviation of 20. Okay? So you would have what? 215 this way, 175 this way, something like this. This would be for the population. You guys good with that? This is what we did on that yellow warm-up. This would be question number 1, the population of cranes. Now, going on to question number 2, it says, suppose that you take a random sample of 100 college students from this population. Okay, so they took a sample, and now we have a sample where n is 100. There would be a 68% chance that the sample mean amount on the bar, oh, yuck. Okay, there would be a 68% chance that the sample mean X bar spent on textbooks would be between which two amounts? Now, I don't see this coming up, okay, but here's the deal. We want to figure out, would you know that 68% is between here and here in the regular population, right? One standard deviation is 68%. But we're not talking the regular population now. We're talking the picture of all possible samples of size 100. So what changes? What did you, the standard deviation. So now we really have a new curve where the distribution of all possible averages still normally distributed. The mean would stay the same, but the standard deviation would change. Would be that standard deviation divided by the square root of 100, or 20 divided by the square root of 100. 20 divided by 10 is 2, right? So really, if we were going to draw the picture now, it's still normal, still centered at 195, but 68% of all samples would fall between 197 and 193 to get 68%. The height of the American woman is distributed exactly as a normal distribution. The mean height of an adult American woman is 63.5 inches with a standard deviation of 2.5. What is the probability that a randomly selected woman is 70 inches or taller? All right, so this is our whole chapter 7. I bet you they're going to do what I did on the warm-up. We're centered at 63.5 with a standard deviation of 2.5. So I'm going to say X is approximately normal. Again, I'm just trying to get you used to the notation. You don't have to worry about that, okay? What is the problem? That you randomly select one lady and she's 70 inches or taller. Make sure you know how to draw these pictures from the story problems. 100% guaranteed you need to know how to make that. So we would do normal CDF from 70 to infinity with a mean of 63.5 and a standard deviation of 2.5, lower bound, upper bound, mean and standard deviation. Second distribution, normal CDF. And 0.00466, which is pretty rare and shouldn't shock me since my standard deviation is 2.5. 63.5 plus 2.5 would be 66, right? Another one would be, it's more than 3 standard deviations above, way above average. Oh. Yeah, hold on just a sec. Guys, work on this for just a sec, and I will be right back. What did you guys think about 11 or 10? Okay. So say you want to form a campus beanstalk club for the tallest 55% of women. What will be the minimum height for membership of the club? Okay. So this is doing it kind of backwards. We're saying, all right, here's our thing. We want to know how tall a woman would have to be if she's in the top 5%. We really want the Z alpha over 2. We really want the Z alpha of 0.5. We want to know what that value is. Okay. So this is the one time you get to use a Z score, or that you have to use the Z score formula. Okay. Well, actually, no, let me think about it. Yeah, you can. You could use a Z score, but let's just use inverse norm. We have the percent, right? We have the mean, we have the standard deviation, so we can just use inverse norm. Inverse norm. Now, in your calculator, you would put in 0.95, because inverse norm goes to the left. But wouldn't this cutoff value be the same if you're talking below or above? Because it's the border. So inverse norm 0.95, and you tell it that it's 63.5 with the standard deviation of 2.5, and somebody tell me what they get. Oliver. Okay, so she needs to be 67.64 inches or taller to be in that club. You could do this with the Z-score formula. We're not going to go there. Any questions? All right. Imagine that all possible samples of size 25 are taken from the population of American adult women's heights. The mean from each sample would then be graphed to form the sampling distribution of the sample means. Draw and label the sampling distribution. So this is the idea of, what are you doing? Are you done? Okay. I'm going to have to grade it for you because I don't have the key, and then we'll talk on Tuesday. For what? Yeah, sleep, yeah. Okay. So again, what's our new mean going to be? The mean, okay, X, let's think about this. X was the height of American women. And those are the problems we just did above. So now we're talking about X bar being the average height of a sample of size 25. So that's how it changes. Okay. So what would the mean still be? It would stay the same at 63.5. What would the standard deviation be? That would be the population standard deviation divided by the square root of 25. Okay. And then it says now draw and label it. So 2.5 divided by the square root of 5 is, just put it right here. So our new picture, okay, is going to be centered at 63.5 with a standard deviation of a half. Etc. You guys good with that? That's all it wants. Basically, it wants you to find the mean and the standard deviation. Okay, and if you go down here, that's this right here. Okay, we did it for proportions. Now here it is for means. This is what we did with the cranes on the second part of the yellow warm-up. All right. If a simple random sample of 25 adult women is taken, what is the probability that the sample mean is over 65 inches? Well, now that we have this, we want to know the chance that it's over 65. So we would do normal CDF from 65 to infinity with a mean of 63.5 and the new standard deviation of 0.5. And I don't know what that probability would be, nor do I care at this point. And I totally had not resumed that. So people watching, this was just doing it now with the new standard deviation. Next question, doing it again with the new standard deviation between these two values. And what I said is, once you have the new standard deviation and you've checked your rim conditions so you know that it's nice and normal, they can give you any version of normal CDF stuff. This up. So say you form a campus beanstalk club for the tallest 5% of women. What will be the minimum height for membership in this club? Include an appropriately labeled and stated Yes. Yeah, they have that on there twice. So unless they're saying based off of your sample, then it would change a little bit, but that's stupid. All right, so any other questions that you guys have? Any other types of problems you want to see? All right, I think you should be good to go. If you want to stay and work on homework or whatever, you're welcome to.